Perfect. Yeah, so we actually I prepared a little bit different type of presentation today about the actionable metadata. Well, first of all, thank you for participation. And I know sometimes it's hard to choose between parallel session, and there's like a parallel sessions here as well. So I appreciate your participation and thanks for picking this session. Well, let's just have a conversation and about something that might change your understanding about the metadata, and that is something what makes metadata actionable. Well, first of all, open source, and I kind of found the session from then today in the morning about the open source, about the collaboration, very, very inspiring. And I would like just to start with acknowledgement of open source. And that open source and Apache Iceberg is a reason why we're all here today, right? So the community is possible because of open source. Open source drives innovation. Open source is a collaboration for all of us. And look just at me yesterday, just arrived from Germany, and right now I'm able just to speak in front of you and present Lakekeeper, present the actionable metadata. And maybe just before jumping into the session, for me to understand, can I just ask you to raise a hand who use open source in your daily job or privately, just to understand like how it's adopted? Okay, there are a few of you. And maybe now kind of a tricky question, who of you has contributed to open source? Okay, so less hands than like as a users. But the good thing is about the contribution, guys, it's not just writing code. Contribution is maybe just to test something, to file the issue, find the bug, or maybe just to improve documentation. Or maybe just, you know, like you have a specific issue on your daily job and you just will go to the project and you will open the issue for that. The simple way to contribute is to start a project, to drive adoption for that project. So what I would like to introduce is Lakekeeper. Lakekeeper is an open source project. It's a REST catalog for Apache Iceberg tables. Lakekeeper is, as Dash just mentioned, written in Rust. And it's licensed at the Apache 2.0 license. And, you know, like the idea is about the contribution, as I said, and here's a QR code, so you can just scan and start a project. And when you're going to leave the session, you can actually say that you are a contributor to the open source. Well, I'm Viktor. I'm creator of Lakekeeper. I'm co-founder of Acamo, and if you have like any questions later on, just reach out to me. Here's email, LinkedIn, or I'm gonna be here around as well. The metadata and data. So what is actually the status quo if you look at this situation right now? So data has been for past 15, 20, 30 years in a spotlight, on a main stage. So all the time businesses act on data. You know, like customer was on a website, let's send him an email. Customer opened the email, yeah, let's give him a discount, and so on and so on. But what about the metadata? Metadata was kind of a necessity. Like, okay, we need to document the metadata. I need to open the wiki page and put inside of a wiki page who is the owner of that data. And no one really took care. And even like Andreas, you just described, like that was a missing part. We don't really know about the data itself because we don't have a metadata. And at the same time, like businesses act on data, but the businesses complains about the data quality, missing data profiling, maybe outdated results, there is no really data ownership, and so on, which is actually part of the metadata and not of the data itself. And in that situation, where we have like the problem and challenges, but the metadata stuck somewhere in the past as a documentation. And the question is like, how did we get here actually? And look at the journey of the metadata. If you look like 1980s and like 80s, 90s, where we had a data warehouse as a single monolithic system where we stored all the data, maybe like a Postgres database or like any database where metadata is mostly like an information schema where you store your tables, views, stored procedures. Monolithical, bureaucratic, very strict, rigid, that gave a structure for us. But at least if you look at the agility, it was really hard to scale your processes around that. And I know from my experience that companies had maybe twice a year an upgrade of their tables or on a data model. Okay, so we said let's solve that problem and be more flexible, and we got the data lakes. At the beginning, maybe on HDFS, and later we got object storages, and we could actually be more flexible here. The main actor was Hive Metastore, which put kind of a facade as a table in front of files, and you could store like Parquet, CSV, JSON, and for the client it was, oh look, that's a table, so I can just play around that table, I can select that table. But at the end, Hive was not delivering the expectation what we had from a database, so it kind of failed maybe. Today, we have a lakehouse with open table formats. And so open table formats, Apache Iceberg, made a promise that we can combine structure from a data warehouses and flexibility from data lakes. That was the promise given by Apache Iceberg or like by open table formats. And the main role here plays actually a REST catalog, because REST catalog manages the metadata. And if you look at that on very simplified architecture of that REST catalog, what you have, like, okay, we have a data which we store somewhere in an object storage. So we have our Parquet or C, Afros. It's all known, it's all good. But if you look at the metadata right now we have a new component which is in charge of lifecycle of a metadata. Or maybe it's even in charge of maintaining the table itself. So you can just go and read the table. And as well, you can just manage the access to that table. The question is, still, is that what we gonna stop here? Because that kind of like the first thing what we need to solve with structure and flexibility, or are we gonna use that metadata for something else? Because still the ownership and governance is not solved through a simple REST catalog as is. And what we have right now in discussion with some companies and some design partners is like, actually to solve the problem of data governance, of data ownership is in metadata, but only if metadata is actionable. And the question is like, what is the actionable metadata? Well, it's maybe kind of self-explanatory, like you have your data, which is not just used for a documentation purposes, but that data is able to trigger a process by itself. So, and that process and that recipient of that process might be a human, it might be an AI, RAG application, or something else. And the very crucial part of that is that we have relationship between data producers and data consumers in that situation, where metadata through the action can enforce the relationship, can describe the relationship. And why do we do that? Because we need stable collaboration and sharing between analytics, between AI. And the question is, what actually has changed in a couple of last years that we have that challenge right now? And the changes, not just on the technical side, that right now we don't have like a single database in a monolithic approach anymore. What we have a decentralization on organization level, and we have decentralization on the process level. So which means if you go to the, like any mid-size or big company, you will find that every unit is right now independent. Like something what we called yesterday a data silo, and everyone was trying to fight the data silo or like break the silos. Right now we call it a data domain. And suddenly data domains are positive, data silos are negative. But the question is, if everyone is independent in a self-service mode producing data products, how are we gonna cope with that situation? Because there is no single place where you have role-based access control to manage the whole thing. And the answer is what we see right now exactly in a metadata, where we can actually deploy and implement the actionability to enforce the relationships. So how we do that in Lakekeeper? And in Lakekeeper, we have some specific implementation, which we call change events. And because Lakekeeper is a REST catalog and it's positioned a pretty interesting place in a center of like the lakehouse architecture, but it's still independent. So what do we have? We have a compute. Let's say it's a compute which runs an alter table operation. And usually that's some operation which will run through the catalog and it's done. But what we can do, Lakekeeper, we can emit that to a queue, that change event, and we can make the reactivity on every metadata change within a catalog. So in that situation, you can imagine that some process will listen to a queue and actually react on that. And the question is right now, okay, we have that in place. So how can we solve something, what I was referring before, like we have all that data domains and we need somehow to govern the data domains. And the conceptual answer is computational governance. So how can we do the computational governance based on the change events? So let's imagine we have a data engineer, which is from a domain, data domain marketing, and that domain is responsible for the customer data, customer metadata for some orders of customers and so on. And so what we have as well as a domain from a sales, and there is a data analyst who actually builds a reporting on top of that data or data products from marketing. And that data or that report, that numbers goes to a management. There is a business process which needs that data to make a decision. And with that decision, they're going to make investments or they're going to make a decision to cut costs and so on and so forth. But today, our data engineer had a great idea to make some changes. Just run an alter table. And that was, let's say, in the morning, that person got inside the organization. And because the data engineer has role-based access control as administrator, that person can do that change, which means for analysts, reports are broken. So no of that reports are able to run anymore. And that is not just a technical issue in that situation, but it's in the business impact for everyone on the management side because they're not able to make a decision anymore. Well, that's something what is not solved today from a perspective of a classical lakehouse. But if we can just apply the computational governance principle with a Lakekeeper and change events, what we can do, we can emit that event to a third party, a data contract engine, which has a contract with actionable SLOs. And the SLO is like some different type of objectives, and one of them is a stable schema, which means in the moment when operation alter table runs, the event goes to the data contract engine, checks the contract, like do we have some service level objectives here? And one is like stable schema, so you're not actually allowed to do that, even though you are an administrator of a table. So what data contract engine will then send back to the data engineer is a conflict message, which means right now what we have two different concepts. One is a role-based access control. From a classical perspective, I can do everything, but the other one is a business constraint as a stable schema, what is expected by a data analyst in that case. As a next step, the system can actually inform both of them, like engineer and an analyst, that something has changed or is about to change. And data engineer can actually go to the analyst and churn the contract and tell to the data analyst, well, you have now a grace period, let's say 7 days, to adjust your reports because I need to make that change. So that is one of the examples how actionable metadata can make the whole situation controllable, or as Christian, my co-founder, says, to make an unbreakable lakehouse, because all that consumption pipelines right now in that situation are not breakable. And this is a major problem in many organizations. And you can just imagine if it's like a huge company where you have this process as a value chain, where someone relies on other numbers. And always is interesting to have a conversation with support personnel who needs just to go and understand where exactly is a breaking change that needs to be fixed. In a discussion with the companies right now, like with this feature, what we can achieve additionally is not just a schema changes that can be prevented upfront, but we can just look at the statistics. And like in presentation before, we have all that AI components. And the statistics is quite interesting because if you have a metadata change, it might have an implication of some AI training model which needs to be rerun, not just because data has changed, but because the metadata has changed. So I just would like to give you like a future outlook on what can be done with actionable metadata. Well, the interesting part is about the analytics and AI silos, let's put it that way. So they are kind of not very connected. So if you go to the companies and you will have a conversation, you will probably find that data engineering don't talk much to the data science. But they share the same data. They share maybe even same business goal to increase revenue or maybe just to cut some costs and so on. And the thing is that we have a unique way to connect both data engineers and data science through the metadata, because the same reason, like if you have a data silo for data engineer and you have a data silo for a data analyst and data silo maybe for scientists, now they can go and sign a contract and explain why they use this data for what type of purposes and what is actually happening if data is going to break their pipelines. The next use case is the lineage between business and technical pipelines or technical information. Right now, you can just find a lot of solutions where you have a technical lineage. You have like table A, and then you have the ETL process, and then you have like a table B, which is a result. And in my conversation, that situation, like, okay, what is the business process that causes that data at all? What's the business process that produced that ETL process? And what is the business step that is going to be triggered by that new data? And there is no information, so we just miss that link. You know, like it's comparable, like if you go back to your school days and you have like your math task and you just need to run the calculation, and then you write at the end of your equation like number 42, the teacher usually asks like, how did you get to that result? And that is some type of information what we miss in this situation as well. So that information resides in some business processes. We have some activity diagrams, we have some business process model notation where exactly this information is kind of stored, but it's disconnected from a technical lineage. The next point is the automation. I mean, that is something what we expect to get pretty soon in our AI agents in operation. I spent 2 days here in the Bay Area, and I see a lot of billboards, AI agent, operator, kind of interesting, like to have a billboard and which talks about the digital world, but still cool. And I see the same type of development that's in 3-5 years, the use case what I was describing before with data analyst and data engineer. There's going to be like no humans maybe anymore in that situation. There are going to be a lot of AI agents, and those AI agents, they need an automated way how to negotiate a contract, how to define the SLO on some specific stuff. There is no way anymore, like maybe as today, that someone is called someone and asks about the data, like, can you give me the data by tomorrow? And the person will tell you probably, oh, let's just postpone it for a couple of days. But exactly through the actionable metadata, I can achieve a very high level of automation. And maybe just the last one is the sharing and secure sharing for the data contracts. In most of the cases and most of discussions inside of the companies, what I see is the concentration on itself, on its one company, and like, okay, are we going to be a data-driven company, and what do we need to achieve that? But if you're going to zoom it out a little bit, and you will see like you have a data-driven economy, you have a supply chains. Let's just take an example: automotive, pharmaceutical, all the different supply chains, and all that single companies in that supply chain is a data silo, more or less. And all of them need the information, and maybe even like the information needs to be flowed back from a manufacturer to the supplier to improve processes, to find the new products, to get like the most needed information. And that is only possible if suppliers between them have a contract, which will actually ensure that data shape is informed, that the metadata is informed. And in parallel, what we have a lakehouse, which gives us a way to share the data between different companies without making a copy. So here is exactly the way where we can just combine the metadata and data and make it both actionable, which will give us like easier way just to become a data-driven economy, not just a data-driven company. Well, that's it from my side. I will just thank you for your attention, and if there are any questions, or maybe afterwards, I don't know how it's planned.
Any questions right now?
Yeah.
Hey, Viktor, thanks. I'm really curious, when you guys first started, what was the Iceberg REST catalog ecosystem like? And what was like the first problem you guys wanted to tackle? And then how did that evolve over time? What are the main problems that you feel like the Iceberg REST catalog should be solving?
Yeah, so when we actually started, we had mostly like tabular as a service, and that was kind of the idea that we need just to build something on our own, because we need to run it in our own environment. And we started to build a catalog because we needed a solution that can integrate with data contracts and actually provide the data mesh principles. That was the whole idea about writing our own catalog.
Cool, thank you.
Perfect, thank you. Yes. Oh.
Am I super simplifying this by comparing it to like a feature on the data observability part? For instance, like reacting to a pipeline is something given like most of the data observability platforms does as well, right? Like including like chains of creating policies so that they try to prevent it or just trigger some events based on it. Is it on the same lines? And if so, like, is there a hard dependency on Iceberg? Is it just because of the metadata offering that it is built, it's reasoning on Iceberg?
Well, the observability will give you maybe what I call a post-mortem message. Your table is broken, and the red lamp will go on, and then you just go and find what exactly was broken.
Yeah, something like a reactive is what happens.
Yeah, and with having Iceberg REST catalog, it gives us actually a preventive mechanism to be more in control. That's something what is not possible if you have like observability will connect to the Postgres table, and someone will change the Postgres table, and then you need just to find a solution. Here we can be preventive, we can just define the relationship, and that is possible with Iceberg REST catalog because it's decoupled from the technology. So it's a decentralized and distributed way of handling the information. So it's possible with Iceberg REST to be preventive. On observability, it's possible, but it's more like post-mortem when the change is already in place.
So here, should I understand this like before the commit happens or before the transaction
Yes.
on the table happened, we just check it at that point in time and then never allow the commits to happen at the first place?
Yeah, absolutely. And you can just define all the different SLOs. It can be still the schema. It can be that you have a specific quality target that you just want to expect before pushing the data inside. So all profiling information, statistics, there are a lot of stuff which is around the table and around the data itself. Yeah.
And the second part of it where you mentioned the future outlook towards both the business catalog and the technical lineage plus the the verbs of the data contracts? Is it like somewhere getting into the line of the Calibra's world of?
No, not
Trying-
not the business catalogs. I'm referring more to the business processes. So like if you look at the business, they don't know about the catalogs at all. What business operates with is a business process model notation, so BPMN 2.0. That's a different type of a thing. And in that business process, you will define like the start of a process, what is happening within then, what type of decisions you need to make, and so on and so forth. And that is something what is actually drives the whole data thing. So without that business, there is no data at all. There is no data sitting somewhere. So someone needs to do the business, someone needs to go and sell or produce, deliver. And if that happens, then we have the data inside of a database or inside of Lakehouse. And that is exactly missing link. Right now, if you will just open your Lakehouse and you will find a table, ask someone, why do we have that table? What process actually causes that table? Or what process will be triggered if we're going to change anything in that table? What will break?
Thank you.
Thank you.
All right. Okay, thank you. We have, thank you, Victor. Really appreciate